day, and welcome to the presentation of Litestar 4D version 2.02, the new version of Oxytec's lighting design system. Let's start analyzing Photoview. The presentation will be split into two parts. The first part will be an introduction to the main features of the new version, and the second one will be the demonstration of the related features. So let's start with the Photoview, the module to manage photometric files. We introduce at the Photoview the new system for the labeling of the products of lamps and luminaires following the European standard 874 of 2012. This system is proposed by Europe in order to classify lamps and luminaires, and it is a system of labels related one to the other. It means that it is possible to classify from the energy point of view a lamp, and in function of the lamps used at the luminaire, we can then classify the luminaire itself. All the labels, both the ones for the lamps and the ones for the luminaires, can be then printed to raster formats like JPG, BMP, PNG, TGA, etc., or to vectorial formats like PS, PostScript, encapsulated PostScript, PDF, and XF formats. Another main update about the program was the introduction of the energy classification following the Italian Ministerial decree on the 23rd of December 2013. This energy classification is the energy classification for the luminaire, and it is called IPEA, Parameterized Index for Energy Efficiency of Luminaires. It was developed in cooperation with Era Luce, which is an Italian ESCO, energy saving company of Italy, one of the main ones, and has been updated and brought into alignment with the new decree. So there is now a new standard in Italy in order to manage the energy classification of road lighting luminaires. But not only road lighting luminaires, it is a set of two indexes. One is this one, the IPEA, and the other one is the IPEI, which will be described later on in a few minutes. This system was already available in the old decree because this is the decree number 2. The first one was introduced in 2007, but at the beginning it was not carrying the A++ classification, A++ class. It was only from G to A+. At the beginning, in 2007, all the luminaires were mostly in the classes from B down to G. But step by step, year after year, the luminaires quality was improved so much that more than 80% of the luminaires were in between, let's say 2 and 1 year ago, in between B to A+. So it was needed to add a new class, and it was added with this new decree, which is quite an innovative decree for the lighting, the public lighting management. Another main point introduced at the Photoview is the Photovlew-Liswin Connection. The Liswin is our interactive electronic catalog where we can load all information related to lamps and to luminaires. In this case, now with this new feature, Photoview can link directly the information available through the Liswin. So for example, if you drag and drop, for example, a ulum.dat file onto Photoview, the photometry will be open, but if you want to change the lamp and use data coming directly from the manufacturers, you can select Change Lamp. The Liswin window will be open, you select the lamp, you confirm the selection, and all data will be transferred automatically to the Photoview. And from here, you can save the photometry into the available formats, like for example, you can start from a ulum.dat and save to an IS, save to a TM14, LTLI, CN 102, etc. Let's come now to the design module, LightCalc. We introduce a new window, a new feature, allowing to manage the import of 3D files. As you probably know, Litestar 4D is capable of managing 3ds and OBJ file formats. And whenever you have a file of this format, you can drag and drop it onto the LightCalc, and automatically this window will appear. This window is allowing you to rescale and rotate the object, position the object in either the drop or the origin point, or in any given point with coordinates defined by the users. And this can be done using this section at your right. So at the upper section, you have the units coming directly from the 3D file. And at the lower window in here, you have the conversion of these values in points of the CAD file into meters, which is the unit used by the program. In the lower part, we have the definition of the parameters, like the scale. You can convert from meters to centimeters, to kilometers, to inches, whatsoever. And it is also possible to select a free mode. So the user can define the conversion from the original unit, from the drawing, into meters. Then here we have the offset. It is possible to define the offset, so the position of the origin at the lower left side of the object, at the center, like it is in this case, or at any position defined by the user. At the right side, we have use drop point, so whenever you select an object from a folder on the desktop, for example, you drag and drop it on here. Whenever you release the mouse button, this point will be the drop point. And you can select to leave the object at the drop point. If you unselect it, it will be released exactly at the center, exactly at the origin of the axis. At the lower part, we have rotate, so the rotation. This object will be used in a demonstration later on, and you will see that it is turned. The original drawing is turned 90 degrees. So we need to rotate 90 degrees in order to fix it at the proper orientation. Another main feature introduced at the LightCalc is the irregular working plane. In many cases, it is very useful to have not a simple regular working plane, but an irregular working plane. You can design using linear or curved segments, like in this case. You can then tilt in any direction of the space. You can also put at a height different from the ground, different from zero. At the irregular working plane, like at the regular working plane you have here on one side of the irregular one, you can calculate horizontal and vertical illuminances like also cylindrical and semi-cylindrical. Always at the LightCalc, we completely changed the layout of the Advanced Road module for the Advanced Road projects. This section of the road module is carrying the road geometry definition and the luminary geometry definition. And these are the two windows that you can have here, you can see here. At the same time, besides the big layout changes, we also introduced a new feature, which is at this column over here, where it is possible to define the pole rotation, and it was split into two, because the program now is allowing you to manage more than one luminaire at the same pole. So, for example, if you have a group of luminaires, 2, 3, 4 luminaires at the same pole, it is now possible to manage them using this new feature. Something more was also introduced at the summary of the results. So, whenever a calculation is finished, this window appears, and it is summarizing the results of the calculation. In this case, we added the automatic checking corresponding to the European standard 13201. It means that when we start defining the project, selecting the standard, the 13201, then we select the class, the road class. So it is automatically defined a set of values to satisfy for the overall uniformity, for the longitudinal uniformity, for the average luminance, for the TI, and for the surrounding ratio. Once we have finished the calculation, the program will automatically compare the values coming from the standard to the calculated ones, and show here if the value is satisfied or if it is not fulfilling the standard. At the same window, at the lower part, we may now visualize the IPEA, so the parameterized index for the energy efficiency of the installation. The Italian decree is saying that it is not possible only to classify the luminaire. It is necessary for a lighting installation to define the classification of the luminaire, and by that define also the classification of the installation. And this is quite clear, because we may have a perfect luminaire which has an A++ class, but if we install it at a pole with a tilting angle of 180 degrees, and so the light is going upward, we won't have light at the ground, at the carriageway, and this is not the perfect energy efficiency layout. So the program will show that even though we have a very good luminaire, the class will be in this case G. It is a sort also of showing the designer the best way to place the luminaire in order to use energy in the best way possible. Also in this case, like in the previous standard, in the previous standards, let's say the IPEA for the luminaire, the A++ class was added because with improvement of the quality of the luminaires from the lighting point of view, from the photometry point of view, all the luminaires step by step were jumping to higher classes. And so in order to define a discriminant, it was needed to add an A++ class. Let's come now to the Liswin, which is the interactive electronic catalog of the program. In here, we introduce also the feature to manage the label in the way to introduce the parameters defined through the photo view into the database so that it is possible to have very efficient and very fast product searches. So, for example, using the Liswin, it is possible to define, for example, that I need a lamp, a compact fluorescent lamp with a class of B or a class of A, and the program will automatically search through the available catalogs. Another feature introduced at the Liswin is the measurement lamp association. The system to associate the measurements to the lamps has been modified in the sense that before it was possible to manage for the same luminaire different measurements, but it was the case of different measurements related to the same luminaire related to the same lamp. It means that in this case, Liswin was capable of managing only measurements coming from different positions of the same lamp inside the optical system. But the Liswin was not capable of managing, on the other hand, luminaires including different lamps, which is coming down to different photometric files, and in case different lamps, because for example a wall luminaire may have a halogen lamp, or it may use a compact fluorescent lamp, or it may use now an LED lamp. In all cases, the measurement arising from the different usage of those lamps will be different. So at any measurement we will have a lamp, and with the new version we can associate to a luminaire different measurements coming from different lamps. During the past 2-3 months, we had a strong cooperation with ASIL, which is the Italian Association of the Manufacturers of Luminaires and Lamps, and we developed together a section of the new website about choosing the right lamp, where we developed some lighting simulations of 3 rooms in a house: a living room, a kitchen, and a bedroom. The goal of this development was to show to the people in the market willing to buy a lamp and give them an idea on how to use lamps in a very simple way. So through the different renderings, we can show that modifying the intensity, you have a different view of the same room, or modify the color temperature, you may have a different view of the same room. The 3 rooms are the ones showed at this slide, and each frame took less than 2 minutes per calculation and per rendering, including ray tracing, for a total of 90 frames. It means that for any room, we developed a total of 30 different frames in around an hour per room. So in 3 hours, we could develop a total of 90 frames. This is possible, such a strong and fast calculation is possible because at our program we use the photon mapping method to run calculations. Let's come now to some new features that we added related always to Litestar 4D. And this new feature added at WebOxy, our website, is the commerce new section. It was developed in a way to be very simple for the people willing to purchase a license of our software. I like to say that our software is available into 3 different configurations. The first one is the open version, which is the freeware version. If you access our website and you select the Litestar 4D download, you will be brought to the page where you can download the open version. This version is carrying most of the features of the program, but some high professional features are included at the Pro version. You can purchase using the e-commerce section. Some extra professional features like the emergency lighting, like the advanced emergency lighting, like the advanced tunnel lighting called Emergency Plus and Tunnel Plus, and also the advanced modules for the photometric data manager, Photoview Plus, can also be purchased over here. So let's summarize. We have 3 configurations. The first one is the open, the freeware, and the other 2, the Pro and the Plus, are available under license. Last, we added a new section called Tips of Litestar. It is a section including the links to a number of videos showing a detailed feature of the program. So, for example, it is possible to have a view to the calculation procedure, showing how fast it is the program, or how to import into the program an OXL file. An OXL file is a file based on the XML technology that we develop in order to complete the missing information that a ULUM.dat file or an IS file cannot carry anymore. Okay, let's come now to the demonstration. In any case, we are also available for a customized demonstration. It's just necessary to call us or to write us at this address. So let's now start with the photo view. And let's now analyze how we manage the new label for the energy efficiency of lamps and luminaires. So let's say that we open our folder. Through here, we select a lamp. We drag and drop. The info section will be displayed once the photometry is uploaded. We select energy efficiency over here, and the label about the lamp will appear. In principle, it is not necessary to define any other parameter because, for example, the program is automatically considering if the lamp is a directional 90 degrees or 120, or it is a no directional lamp. It is automatically uploading the flux, define the rated power, but at the end the user should define which is the ballast used at the lamp. So in this case it is an halogen lamp with a ballast and external ballast. The big difference is that automatically the program will convert, considering coming from data available through the standard, applying a coefficient which makes a change into the power of our lamp. which is the label expressed in kilowatt per hour on 1,000 hours. This label can then be saved as an image. We can select different file formats, or it can be saved to PostScript. It is also possible to save to PDF or to DXF in case. But let's come now to the label for a luminaire. So if we select this luminaire, we have to then select from the pull-down window that we want to apply the EU regulation 874 for luminaires, and this label will appear. In here, it is not possible to define the label through the photometry, because the label of the 874 for luminaires, it is based on the lamps used at the luminaire. So, and it is based on the energy efficiency of the lamps used at the luminaire. In this case, let's say that we have a luminaire for high pressure sodium lamps. We may say that the energy efficiency class of those lamps can be in between, let's say, C and D. So this, in this way, it will be show the label. Then we have to define if this luminaire it is supplied with a lamp or not. Let's say that it is supplied with a lamp of C class, and automatically the description will be placed here, and this description has to be shown at the language where the luminaire will be sold. And also the same for the upper text over here. It is also possible to define if the luminaire is based on LED modules, and this LED and parentheses will be displayed, and at the end, if this luminaire is excluding some lamp classes. So for example, if we don't want to sell this luminaire, or it is not possible to sell this luminaire with a B-class lamps, it will be shown in this way. As before, it is possible to export this label to a raster format or to a vectorial format. Let's come now to the IPEA index and to the IPEA energy classification system for road luminaires. This is a luminaire coming from, it is a road lighting luminaire. So it can be used also for our classification. In the same way like we did before, from the drop-down window, it is possible to select IPEA standard, and automatically the classification will be displayed over here. But be careful, because whenever you import an LDT, so a ULUM.dat file or an IS file, a single power will be available through that file, which is the power of the total consumption of the luminaire, including lamp and ballast. So in any case, the program, the module, is managing two different powers in order to run out the classification. So in this case, it is necessary to modify the lamp power and put 200 50 watt. And as you can see, the class changed. So it is essential that you always pay a look to the two powers over here. The other parameters are taken from the file itself. Also this one, but you have to be very careful about the definition of one of the two powers. Why? Because sometimes manufacturers are supplying the information as a total power. Sometimes they are supplying the information at ULUM data or IS files, including only land power. So you have to be very careful in order to define one of the two missing. We analyzed the problem and tried to solve it using the OXL file. The OXL file wanted to be the evolution of the ULUM data and IS files as we know them right now, because we have a great number of standards now describing in different ways the luminaires. So from our point of view, it was essential to manage different data at the same file. We analyzed different file formats and found that an XML file could be the solution for us, and so we developed the OXL file format. At the OXL file format, it is possible, for example, to define the two powers, like it is also possible to define many other parameters which are not included at ULUM data or IS file. So if we drag and drop the same luminary but expressed in OXL file format, we will see that automatically it is carrying the two powers, so automatically the classification is the real one, and I don't have to apply any change to the values over here. Let's come back to the lamp and let's now see how we can use those data at the Liswin. So, for example, let's say that I don't have this lamp, which is the 41840 from OSRAM, and let's say that I want to have it at my database and I want to include the energy efficiency of this lamp, unless it is already available at the OSRAM catalogs. So let's say now that I select this icon, which is manufacturer's web catalog. It will be open over here, and from here, once it is available, I can select from the product list that I want to have a 41840 lamp. Find. I have three different solutions. The one I use here, it is a flood one. So I select this one, and from here I drag and drop the image of the lamp onto the Liswin. The program will automatically transfer the lamp to my local database, and from here right-click, Edit Lamp, select energy parameters, and I can input the missing parameters like the energy efficiency. The energy efficiency index, in this case, okay, I have to go a little bit down, 1473. 1473, and the class, which is a D class. I save it, and automatically it will be uploaded to the database. It is now possible to run a search saying that I want to have all lamps with a D class, energy parameters with a D class. If I select this one, I found only one lamp, and it is this one. Okay, let's come now to the light calc and let's show the different features, main features we introduce at this new version. The import of 3ds files. So we open our folder, we select 3ds, we select this file, we drag and drop, and in here we find that the object is rotated 90 degrees. So it is immediately necessary to rotate it 90 degrees and pull it up. Then we check the dimension and see that the original dimensions are corresponding to the meters and to what I expect about this object, which is a kid toy for the parks. Then I define if I want to use the drop point or not. As you can see, it will be automatically displayed over here that there will be a different position of the object corresponding to where I dropped my mouse. In any case, it is also possible to define a different position of the object. Then it is possible to define the origin of the axis. We can put it down to the left. We can put it centered to the axis, or none, or customized. If we select customize, we may here define the coordinates x, y, and z. Once we have finished, let's say that we leave it none. Let's say that we want to rotate also following the z, the vertical axis. Once we confirm, the object will be introduced over here. Let's say that we introduce also some changes at the windows to import the XF files. We included also other features, but mostly the main one is that it is now possible, once we drag and drop the XF file onto the working plane of Light Calc, we can define the drop point. So in case we want to leave the object, the XF file, to a specific position defined by the mouse, it is also possible now. So we confirm, and that's it. It is, in any case, then possible to move the object, because anything introduced at the Light Calc can then be moved. So in this case, we can move the XF file to the proper position. Or, obviously, it is also possible to move the object itself. Let's come now to the irregular working plane. We select the icon Custom Working Plane, and let's say that we want to define this irregular line as a working plane. So we start at this point. We then define this one. With the right button of your mouse, we may define a curve. Again. And step by step, once we have finished, we press Enter, and it will be automatically closed. We may define the height. So, for example, 1 meter. Once we confirm, it will be shown in this way. This working plane can also be tilted in this way. We select this one, or we select the properties, we select the object, and define over here the rotation in an analytical way. But it is also possible in a graphical way. So let's say that we want to tilt, and we tilt it in this way. Let's say that now we had a luminaire over here. We pull it a little bit up. We see it from the top view in order to properly place the luminaire, and now we run the calculation. Once we are finished with the calculation, we have the rendering, and we also have the values. We select the working plane, we select values, and the values will be displayed. Let's say that it is possible to visualize the values, but then convert the visualization into the false color diagram. We may also have different scales from here, so the linear scale or the logarithmic scale. Once we are finished, we confirm, and that's it. Let's come now to the road module, the module for road lighting. So I don't save the project. I select Advanced Roads. This window will appear. At this window, we may define the road geometry, or we may define the luminaire geometry. Let's start with the road geometry. Let's say that we want to start defining the road starting from a pedestrian path. As you can see, immediately it will be displayed at the working plane over here. Now, let's say that we want from here to head always at the cycle pedestrian zone. We want to head a cycle path. In this case, the cycle path will be headed over here, and clicking here, it is possible to define a different color. Let's now select this one, and let's now say that I want to add a lane, so a zone which is a carriageway. It will be automatically added. From here, I can duplicate and insert other lanes corresponding to the same carriageway. Then I select the carriageway, and I add a sidewalk on the other side. So step by step, I can characterize my road. Let's say that now I want to add some luminaires to the road in order to have the lighting of this road. So I may select a ulum.dat file from here. I select this one and I put it at this window. The parameters will be loaded, but in any case, being a ulum.dat file, the original file, we don't have the image. If we want to have the image, we simply come to the Liswin, we select luminaires, we select a manufacturer of luminaires, like this one. We simply drag and drop the image over here, and it will be automatically loaded. All data will be automatically loaded, and from here I have the row. I can modify the parameters, or if I need to add another luminaire, maybe placed with a different orientation, with a different height at the same pole, I simply select the row. I add a new one. I select the same luminaire. So another one was headed with the same origin, with the same coordinates, same height. Let's say that we installed the second one at a height of 7 meters. Virtual calculation, it means that we consider all the luminaires before and after the section of the road under consideration, and from here I leave it this one at 1 meter. This one I rotate 90 degrees. Once I have finished, I confirm through this button, and it will be displayed in this way. From now, I can start with the calculation. In this case, it is an outdoor calculation, so it can be performed only considering the direct component of the interreflections. And in few seconds, we will have the total calculation. Once we have finished, we press on close, and we see that having defined before, we didn't define, but it was taken as a default value, because whenever you start a lighting calculation, the EN13201 standard is defined, and the first class is ME1. So in this case, for the average luminance, we have that the installation is fulfilling the requirement. In this case, the overall uniformity is not satisfied. In this case, the longitudinal uniformity is satisfied because we have 0.74 in place of 0.70, the TI, and the surrounding ratio. Let's say that we want to analyze if from the energy efficiency point of view, we are satisfying the class required by the standard, at least our standard. So we want to visualize the IPEI, and in this case, we found that it is C. The decree over here in Italy is saying that a C class is an accepted one, and it is the lower limit. So now, if you want to improve the class, you have to modify the orientation of the luminaires, the tilting of the luminaires. You have to modify the luminaire itself in order to achieve a better class. In this case, it means that the system, the installation, is not perfectly using the energy to light this road. Let's come now and come back to the Liswin. And let's consider how the Liswin now is working from the point of view of managing different measurements related to the same luminaire, but considering different lamps. So we have a case of this manufacturer. In this case, this luminaire is characterized with different photometries, as you can see here. And you can see that the lamp is changing in the same way like also the photometry is changing. And in function of any photometry, we have a different lamp. This is a 100-watt lamp. With the other photometry, it is a 150 lamp. So, in this case, with the new version, it is possible to realize what we did, what we said before about having one single luminaire, and at the same luminaire we may use different lamps which are giving different measurements. So we can manage a single luminaire, different measurements with different lamps. Let's come now to the website of ASIL, which is the Association of Lighting Products Manufacturers over here in Italy. And let's come to their website. In here, we may click over here and see the 3 rooms that we developed for ASIL. If we select bedroom, we have here the bedroom, and we may modify the flux. It's a sort of dimming light, and we may also change light. So this is a very simple tool showing the people in the market that they have to be very careful when they select a lamp, because the color temperature is essential for a good lighting of their room or their kitchen, their bedroom, their living room. Let's come now to the e-commerce. If you come to our website page, the home page of WebOxy, you may select e-commerce, and from e-commerce this window will appear, and it is the window where you can configure your license. So, for example, it is possible to define the quantity of licenses you need. It is then possible to define the number of years, and in function of what you select, you may have discounts in function of multiple licenses and multiple years. Last but not least, the tips. Here you have the page linking to some tips now available. Let's say that in close future we are going to have more and more tips about the different subjects of the program, and the ones now available are for the import of the XF files from CAD, the calculation and rendering and ray tracing with the photon mapping. This is the method that we use for the calculation, which replaced the radiosity, and then how to import an Excel file into the database. So I thank you for your attention.